Hello one and all. Today we are tackling a HackerRank problem known as modified Kaprekar numbers. It is an easy difficulty problem. As usual, I'll be going over the problem, giving you some time to do it on your own, and then going over my solution. All right, here we go. A modified Kaprekar number is a positive whole number with a special property. If you square it, then split the number into two integers and sum those integers, you have the same value you started with. That is a Kaprekar number. You take it, you square the number into a string and then split it in half, and then you try to add those two together. And it kind of gives you an example here. So imagine that n equals 5. So n squared is 25. If you split those into two separate strings, 2 and a 5, you can add them together to get 7, but 7 does not equal 5, and therefore it is not a modified Kaprekar number. However, if you use n equals 9, that will be 9 squared is 81, and you can split 1 into 8 plus 1, and you add that together to get 9. Well, certainly 9 equals 9, and therefore 9 is a Kaprekar number. And you are supposed to print the list of modified Kaprekar numbers between the two values, P and Q. So basically you're given a range, and you need to find all the Kaprekar numbers and print out each one kind of like as a space separated list, or print invalid range if there are no modified Kaprekar numbers in there. And that's the idea. I don't know why this website is all like wonky like this, because I guess the UI got changed, but I don't know, maybe they stopped caring about the full screen mode. Anyway, I'll give you some time to do it on your own, and then I'll go over my solution. See you soon. Okay, so for the most part, this isn't too difficult. I'm just going to loop over the range between P and Q, and I'm just going to check to see if that number, for each number, if it's a modified Kaprekar number. How do you do that? You kind of do just like the algorithm more or less tells you to do. You square the number, convert it into a string, and then split it. So you do need to determine the midpoint. So I'm going to take the length of that string and do floor division to get whatever the midpoint is, and then kind of split based on that left and right. Then you take those left and right splits, convert those to integers, add them together, and see, okay, does this number equal the original or not? So I have the number 55 here. If you square it, you get 3025. You split that into 30 and 25, and then you make those into integers and add those together, and you'll get 55. And certainly 55 equals 55, and therefore 55 is a Kaprekar number. So here's 18 squared to get 324, and I'll have to split that somehow. And I'll note here that for the split, the length being 3, you do floor division, so that's 3 divided by 2. You'll get 1.5, and you do floor division, meaning that you just get a 1. So you'll actually split with an index of 1, but that's exclusive. You get 3 and 24, add those together, you get 27. That's not equals to 18, therefore 18 is not a Kaprekar number. So let's go into the code. And here I have the main definition of the function here, but I have this like helper function which does the actual kind of true false value if it's actually a Kaprekar number or not. So first we're given P and Q, and basically I have here a list comprehension which goes through each number within the range of P up to Q plus 1. I have to do plus 1 because range by itself is not inclusive, so you need to actually add 1 just to make the Q value actually show up and be processed. So for each one of those numbers, I'm checking to see if that number is a modified Kaprekar number. If that is true, then we will return the string form of that. And I'll tell you why I'm converting to string here, because later on for the printing, you need to actually print the numbers, and they can't be integers, they have to be strings, annoyingly. So that's what this join method is doing. But anyway, so this is mod cap function is taking in the number. It's doing exactly what we said. We're squaring it. We're getting the mid length, which is the length floor division 2. And once we do that, we split that squared string into the mid on the left and on the right. And you notice here I have or 0. So what I found was that sometimes you would split and there would be only like one digit, like for example 1 squared is just 1, and so you don't have really a left and a right, and so you have an empty string. And so it helps I just have a value that's there for those empty strings. So I put an or 0 for both of these just in case that ever happens, that they get handled, and you can convert those to int and add those together and say okay, is the original number equal to the sum of those two? That's basically it. Let's run some code and submit some code. Here we go. All right, so that looks good. Time complexity is not that crazy here. For the most part, there's not too much going on here. This is big O of basically Q minus P, whatever that value is. Those are actual raw numbers there, so that will be what you're iterating over here. That's how many elements you're considering. For the is mod, each one of those is going through this. So your stringifying a number that's being squared. So stringifying does take something into account, but for the most part, it's pretty negligible. The numbers themselves are like maybe length 4 or whatever. It's not that big. Whatever the length of this string is, we can call it maybe k. So you might say this is, okay, this is big O of q minus p, and for each one of those it's like big O of k, because this is big O of k here, k being the length of this string. This function has a time complexity of big O of k. So I'd say here the total time complexity equals big O of q minus p times big O of k. Kind of like that. It's a little bit messy, but honestly, it's not that complicated. I'm being like super specific here with this whole like k. It's not really that significant. Hopefully that was helpful. If this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I'll see you next time. Take care.